Alright everyone, uh, this is my tutorial for how to set up an Excel document, analyze the raw data that you have, to word that raw data, which is now going to be summary data, into a result section, how to go back to Excel to create the visuals that are needed using the summary data, not the raw data, to insert that into Word, and to label them properly. Alright, right now I'm making this in the fall of 2014, so this is going to be for my honors students in Life 102 here at Colorado State University, and this will get used for my Life 103 and probably any other Life 103 students that want this. Alright, so setting up the worksheet in Excel. Alright, so to set that up, for my students, I'm going to have this set up. For other students, you may have to do a little bit of work to go ahead and set this up so that it's easy to run through. On the left-hand side here of the table, so up top I have a little bit of how-to if any of the statistics are still giving you trouble. In particular, how to evaluate your t-test that I'll cover in a little bit. Alright, but for the raw data itself, on the left side here I have subject characteristics. I have subject number, age of the subject, the sex of the subject. For fun, I'm going to add body mass index. I actually made these up. I'm not going to ask any of my students to tell me their body mass index. So probably for all my students this is going to be made up data. But treat it like it isn't. Basal. So this is your control condition, right? Beforehand, before you do something. And we measured for dependent variables heart rate and blood pressure. For blood pressure, you have the systolic and diastolic pressures. Alright, we did the control condition twice, so 2 repeats so that we're a little more sure of our data. Then I have some room because each person did it twice, so I want to find subject number 1's average. And then I have my treatment, round 1 and round 2. Again, 2 repetitions of our treatment, and again some space here. Alright? The data in the end that I will present is only in green. All of this raw stuff up here is going to make our summary data, but I will not present any raw data. This is deceiving maybe when you only have 24 students like this table, but imagine you had 1,000 subjects. You definitely do not want to present any of the individual data when you have 1,000 or 10,000 people. All right, you want to know overall what happened. Okay, so let's first get subject characteristics. All right, so sample wide. I want to know the average age of my subjects. So this is in Mac. Microsoft Word on a PC will be a little bit different, but you're going to find this symbol and select average. Average almost always shows up, and it's going to take a guess at what data you mean for it to be referencing. So it has now inserted a formula here, average of these boxes, and that is correct. So press enter, and there's my average. For the next one, I want standard deviation. So the variation around that average, all right? How far is 68% of your population on either side of your mean? It's a measure of spread. Where are the majority of the people? So I don't see it quickly when I look here, so go to More Functions. This window should pop up. And go ahead and search for it if you don't see it still. Standard deviation. Sorry, I don't know why this is giving me some trouble. STDEV. If for some reason that doesn't come up as standard deviation when you type it, STDEV works. Alright. Right click it, and again it's going to guess. Make sure it guesses correctly. Right now you can see it's highlighted over my sample average. That's incorrect. I do not want that. So go ahead and tell it where you mean it to be. Alright. Do not include a green box in this. Press enter. I have a standard deviation of 2. Alright. I'm going to show you a little trick in Excel. This will save you a lot of time. Right? So sample average formula is referencing whatever is directly above it. Alright, that's what I told it to do. I also told the standard deviation to reference whatever's above it, but not the box immediate above it. So if I want that to work for all of these, highlight the boxes and see this little square that appears at the bottom right? Grab that and drag it over. Alright, obviously I can't take an average of the letter M and F, so that did not work. I can't take standard deviation of that either. However, it did, and to check and make sure your reference stayed over, double click it and look. The box moved over. Convince yourself that that worked here too. The box moved over but did not include a green. Alright. For gender, be creative. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have, do the equal sign if you want to do some math. I have 18 out of 24 students. Make it a percentage times 100, right? 75% of my subjects are female. Percentage female. Percentage. Okay. So, get into Word. Right. Let's move this so I can easily see my statistics. Results. 24 young adults average age with an average age of 20 and then insert a symbol. So you can go up here to insert, symbol, symbol browser, and again a window should pop up. And if you don't see it right away, do some scrolling. You are looking for a plus minus symbol, because remember standard deviation is showing you the spread about a mean. Sorry guys, I am on a computer I'm not normally on, which you guys probably will be too. You'll be using personal sometimes on campus. Give me a moment here, I do not know where this thing is. But if you can't find it, it's a good way to figure that out. Alright, open up a web browser. Safari. And just Google it. Plus minus symbol. There it is. Anytime you need a symbol, this is the easiest way to do it. So copy paste from there into my document. If you can't find it and you're struggling, just find it on the internet. All right, average age of 20 plus or minus 2 years. Keep typing. This difference in format I will fix later. All right, results 24 young adults with an average age of 20 plus or minus 2 years. Completed the treatment. You guys should be specific, right? The treatment. Whatever the treatment is you guys have done. Have completed the taboo game experiment, which is what this data set is from. All right. Subjects were, right? We have 75% female and a BMI of 22. BMI is a measure of rough idea for overweight status. So BMI of 22 fits under this normal category. Right? So let's fill in that other piece, the gender or sex and their weight status. Subjects were 75% female and were of normal weight. All right, so we have described the subjects and we said what experiment they did. If you have more subject characteristics in that, by all means, add them. But that's pretty much all I have for this example. All right, back to your data set. All right, so we want to figure out what happened to the dependent variables, right? So control and treatment, what happened to heart rate as a result of the treatment. So for this one, we're going to use the formulas again, and we're going to get average. All right, and again, it's going to try and guess, but this time it's definitely not going to be right, right? Because there are multiple variables over there, when all I really want is 2 of them. That heart rate, comma, that heart rate. So now you'll see my formula reads equals average of the blue box and the green box. The next part seems hard, right? I'm going to have to do that for every one. Not the case. Remember that little box that showed up? It's going to move the reference that was on heart rate over to systolic if I move it by 1. If I move it by 2, it's going to move it to diastolic. And similarly, move it by 1 to systolic, move it by 2 to diastolic. So go ahead and grab that box and move it over 2. Make sure that was correct. Systolic. There it is. Blue is now on systolic and green is on systolic. Diastolic. Again, moved it to diastolic. Alright, now let's move them down. Highlight all 3 and drag this down. Alright, we've lost some of the pretty formatting, but that's okay. If these are wild and outrageous with the number of decimal places, you can adjust that. I will show you how to adjust that for these. For now, I'll leave it. Since I'm not going to report that, I don't care how huge those numbers are. Alright, so we'll quickly do the same thing over here. So you'll see it one more time, but I'm not going to draw it out. Alright, equals average of, I don't want a lot of them, I only want my 2 boxes. So average of that heart rate under treatment round 1, comma, this heart rate under treatment round 2. Drag it over 3. Drag it down through all subjects. Alright, still too unruly to be able to tell what happened. So I want the sample average. Not the individual averages, but a sample average. So let's do average again. This time it's going to guess properly, right? It's guessing that whole region, which is correct. Do the standard deviation as well. Before I change that over, I'll do average over here. Indeed, it guessed correctly. Alright, input standard deviation, stdev. It's going to guess incorrectly by the way this is set up. And if it starts happening and this gets unruly, just start deleting in things inside of the parentheses. Alright, highlight your numbers when that's empty. Press enter. Alright, average and standard deviation. Drag them over. Do your standard deviation here. Alright, drag them over and do a spot check. Make sure this was correct, right? There's my average of those, standard deviation, same spot. Alright, we're good to go. This must already have some formatting from when I was playing with this earlier, but you can see over here the formatting did not stick. So those are crazy unruly numbers, right? And you can see we don't even have any decimal places in these to begin with. So let's get rid of the decimal places. Highlight anything you want to change the format of. Right click and go down to Format Cells. You will get this screen, and the generic, by default, it's just called general. These are numbers, and you care about the number of decimal places. So here's where you can adjust it. Decimal place 1, 2, 3, whatever. I'm going to suggest 0 to make these. We didn't record it initially in decimal places, so it seems silly to represent them in decimal places. Alright. So now you can see sample average before was 79 heart rate and 79 heart rate after treatment. Systolic was 107 before and 132 after. 68 diastolic blood pressure before and 89 after. It certainly looks like heart rate did not change. It looks like systolic blood pressure changed, and it looks like diastolic blood pressure changed. For now, I'm going to go back to the Word document. I'm going to report it as is without any opinion in this whatsoever. I'm going to grab my Word document. Again, I'm going to leave room so I can see these down here. And just report the numbers without saying change or didn't change, or different or not different. Any of those adjectives. Adjectives? I think that's the right word. Alright, so just report them. The heart rate before treatment was 79. Make sure you include units, beats per minute. And after treatment, it was 79 beats per minute. Systolic. This is when science writing can be very boring. When you get a better handle on these, you guys can feel free to be a little more creative in here, but for now, honestly, just keep it cut and dry. Systolic blood pressure prior to treatment was 107 millimeters of mercury, and after treatment it was 132 millimeters of mercury. Do it again. Diastolic blood pressure prior to treatment was 69 millimeters of mercury, and afterward it was 89 millimeters of mercury. Alright, now, first thing, notice up here, I added my standard deviation. We're going to want to do that down here too. So, go ahead and grab that symbol again, copy it after each one of these averages, but before the units, because standard deviation is the same units. So that was 79 plus or minus 10. 79 plus or minus 13. 107 is plus or minus 12. 132 is plus or minus 17. So systolic plus or minus 12 millimeters mercury. 132 plus or minus 17 millimeters of mercury. Diastolic blood pressure 68 plus or minus 9 millimeters of mercury. And afterward, we got 16. Alright, so we did that straight without any interpretation. In order to get some interpretation, we have to have some rules. So in your methods, you should have wrote the rules that you're going to follow. And I add them to the top of these spreadsheets for you guys, but it should be in your methods, right? You're going to judge the p-value based on an alpha. Alpha is usually set to 0.05. There's all of it. So compare the p-value to an alpha significance level of 0.05. So we need to create p-values and then we need to compare them to 0.05. If it is less than 0.05, your alpha, you reject the null, and that supports the hypothesis that something is different. Whatever those variables are different. If it is greater than 0.05, you fail to reject the null, meaning there was no support for your hypothesis. There is no significant difference between your dependent variables. Alright, so let's do that. Define what you need first. Alright, so I need 3 dependent variables, right? We measured heart rate, systolic and diastolic blood pressure. Let me just reorient the screen just so you guys can see clearly. So, dependent heart rate, systolic blood pressure, diastolic blood pressure. Make sure when you bring these over, if you're still using the abbreviations like I am right here, that you've defined them in your document. And what conditions? I only have one condition, right? I have a comparison between basal or control and treatment. So control versus treatment. If you have other treatments, control versus treatment number 1, treatment number 2, treatment number 3, then you'll need to run multiple t-tests. We only have one in this example. So get back up to your formulas, and we want a t-test. Alright, what you want is this to pop up. You can build it down here in the parentheses if you know what you're doing, but this is the easiest way, is to get this field. So it wants array number 1. you want to highlight all of the heart rates for your subjects. Right, so highlight all of those for array number 1. Go to array 2. Oh, back up. No, that's fine. So sample individual averages for basal treatment or control treatment, and individual averages for treatment. So array number 2 is your heart rate here. That average for each individual. Alright, tails, we're not going to get complicated in this class. Just use 2 tails. And type does matter. We described it in the textbook, I believe, whatever book, depending on which class is watching this. But there's paired and unpaired. And they give you a key up here. Paired equals 1. 2 sample equal variance is 2. 2 sample unequal variance is 3. You're either going to choose 1 or 2. Either the paired, meaning the same subject, is this line number 1 as over here. And in this case it is. This is the control value for before the game for subject number 1, and this is the treatment value after treatment for subject number 1, same person. So we have a paired t-test. There's your t-test. Alright, so when you compare heart rate before treatment and after treatment, 0.9. 0.9 is bigger than 0.05. Therefore, there is no difference between heart rate. That's what we expected, right? 79 looks a lot like 79. Right? The game Taboo did not have an effect on heart rate. Head into your Word document and go ahead and put that in. Heart rate did not change as a result of Taboo. P equals 0.09. Let's make the same sentence for the others. So we need that t-test. So this time I can't copy it down because it's going to just drag the box down 1. In reality, I want it to draw over. So the way I've set up this table, it just requires that I do it again. Alright, so array number 1, systolic, individual averages. Array number 2, systolic, individual averages. Whoa, what happened? Again, you'll mess this up just like I am. Systolic individual averages. Array number 2, systolic individual averages. Still 2 tails and a paired comparison. Do the same. Diastolic. Array 2, diastolic after treatment. Tails 2, type 1, and equals. Alright, e to the negative number. This means they're decimals. So again, if you would like to make this pretty, a little more understandable. If e's work for you, that's fine. I'm just going to make sure you guys understand that these are teeny, teeny, tiny numbers. So, systolic, is it less than 0.05? Way less than 0.05. So according to our rules, that means that the number 107 and 132 are significantly different than each other. It is not just chance that 107 is different than 132. If it's not chance, then it must be the treatment. Alright? Same again. Diastolic blood pressure way lower than 0.05. Therefore, 68 and 89 are significantly different than one another in support of your hypothesis. It seems as though your treatment affected systolic and diastolic blood pressure, but did not affect heart rate. So go ahead and add those numbers. You're going to have to do it after either one, or you can put them together. I'm just going to do one. Both systolic and diastolic blood pressure are significantly different after treatment. Alright. Cite your data. P is, in this case, since they're so small, I just say is less than 0.0001. Right? That's way less than 0.05. Alright. Now, there's my written section of the results. It's not a lot of information, not a lot of writing, a lot of information. Correct that. Not a lot of writing, a lot of information. Alright, we're almost there. Now, we want some graphical elements to this. So, I want to make some charts. In scientific papers, we just call them figures. You're used to calling them graphs. It's fine by me. Alright, so I want a heart rate graph, a systolic graph, and a diastolic graph. The easiest way to do this is to create mini tables. Let me first show you what this would look like if you did raw data. This is not what I want you to do. Right? Heart rate. Now, let me show you the right way first, then I'll show you the wrong way. Make a mini table of your summary information. Alright. I want control, taboo, after taboo. Alright, nice and descriptive. Using the word treatment, don't make the reader do extra work. Make it descriptive. This is after playing taboo. Alright. Heart rate. You can just copy those and paste them as many times as you're going to use them. We're going to use them 3 times, right? Systolic blood pressure, diastolic blood pressure. In case you ever change anything, it's best to just reference rather than rewrite. So control heart rate equals, press the equals key, and then go click it, 79. After taboo equals sign 79. Equals 79. Control systolic is 107. Systolic after taboo is 132. Control diastolic is 68 equals that box. After taboo equals that box. Alright, here's what you need for your graphs. Highlight those 4. Go to Insert, Chart. I happen to be a column fan, but if you really like lines, it's probably fine. There we go. Here is our graph for heart rate. 80, 79, 79, 79, 79, 79, 79, 79. Oh, that's weird. Series 1, that's weird. Alright, you're not done yet. If the legend isn't helping you, delete it. Excel will by default try to show you a difference between two values, because if I showed you more decimal places, you'd see that's 79 point blah 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 different, right? But what did we see? The t-test said heart rate is not different. This graph makes it look different. So that is not what we want. So format axis. Let me move this down a little bit. Right click on the axis, format, I want format axis. Format axis, minimum 60, maximum 95. Alright. These numbers are basically within range. If you go up here and scroll, you'll see pretty much all of people's numbers came in within that range. Here's one that's way up at 118, but for the most part here, we have numbers between those values. So that's why I chose those numbers. Alright, doesn't look like there's much of a difference. That reflects our t-test. Make your next one for systolic. Oh, wait, whoa. Let's give this guy, he needs a name, right? So I want, in my chart layout, axes titles. This is, again, a little bit different in PC, but you should be able to find them pretty easily. It's like chart elements. Add chart element, and you should be able to get to it. So vertical axis, I want a rotated title, and this is pulse in beats per minute. If you really want, you could add a title for the X and say conditions, control condition and the after taboo condition. I think this is descriptive enough as it is, but feel free if that makes you more comfortable. Highlight your next for insert. So this time I'm going to go through pretty quickly, okay? Insert my chart. I'm going to make it a column. Do we have a difference this time? Yes, systolic blood pressure is different. I'm okay with the way this is represented. The key that it tried to insert is ridiculous. It did not give me axes title. It never does. Chart layout, axes title, vertical, rotated. This is pressure in millimeters of mercury. Highlight the last ones. Insert chart. Select column. Delete the key. First, do we need to adjust it? We have a nice big one, right? 100 to 0. If I wanted to make these physiological, I could probably chop this off here and chop this off here. I'm okay with it. But we do need a title, right? And it is different, right? Again, it's less than 0.05. So Excel is showing us a difference, and I'm okay with that. Chart layout, axes title, vertical, rotated, pressure, millimeters of mercury. Alright. Grab them, bring them into Excel. Or sorry, Word. So Control, copy. Bring up Word. And paste it in. Alright, you want to give this a name, give it some labels. So this is, remember I said charts are actually called figures. Figure number 1. And usually you're a little descriptive down here. Again, this is going to feel very repetitive, especially since we have such a small data set. But go ahead and say this is average heart rate before and immediately after taboo. Alright. Since you've labeled it figure 1, go ahead and add a reference to it up here. Right where you talked about heart rate, put in a parenthesis and say figure 1. Now someone can go look. After you report this, they can go look at it. Let's do the same thing for the other two. Control C for pressure. Add it in. Figure 2. Average systolic blood pressure before and immediately after taboo. And that's figure 2. Go ahead and add your reference to that. Systolic blood pressure, reported measurements. Figure 2. So I don't have to come back up. I'm going to do the same thing for diastolic blood pressure. All right. Figure 3. Grab your last chart. Control C. Drop back in. Figure 3, average, diastolic blood pressure before and immediately after taboo. Alright guys, last thing, let's make a pretty table. Alright. Heart rate. Systolic. Actually, we can go the other way. So, control. After taboo. Students. T-test. Alright, so we want heart rate in beats per minute. We want 3 spaces for that. You'll see why in a minute. For each dependent variable, you want 3 spaces. So you can do a merge and center over those 3. Go another 3. Merge and center for systolic. Merge and center 3 of them for diastolic. You can merge and center all 6 above that because those words alone are not enough, right? This is blood pressure in millimeters of mercury. Alright. Go back to Word. Grab that plus minus symbol and put it in the middle of your 3. Apparently that doesn't work. and shrink that middle one right up. If you double click the right hand part of the column, it'll shrink to whatever's the largest thing in that column. That happens to be those. Alright, that's the hard part. Everything else is just bringing the data over. So, heart rate, control, 79. 107 equals the box with the 68. Do the same thing for standard deviation, equals that box, equals that box, equals, nope, not that one, equals that box. Oh, that was incorrect. I'm not following my own chart. After taboo, heart rate equals that box. Standard deviation equals that box. Systolic. Here's our 107 versus 132. Deviation equals that one and that one. Diastolic equals your box with your 68. Diastolic after, box with 89. Standard deviation equals that box with a 9. Standard deviation after equals that box. Alright. Do the same thing you did before if you want to crunch these down. Alright, so far everything still looks pretty good. Students t-test. I would merge and center that. Get rid of what was in there. Get a little overzealous. Alright, so merge and center those three under each of these. Alright, students t-test. Remember we did control versus taboo for each one of these. So equals, go to the one at control versus treatment for heart rate, equals that box, equals that box, equals that box. Go ahead and format these because that looks absolutely ridiculous. Format cells, go number, and 2 is probably fine. Alright. On an assignment, so that you prove to your teacher that you got the correct p-value, even though these are ridiculously small, I would make them bigger just so that your teacher knows, me if it's me or any of the other TAs, that you did get the correct value. So we can keep these looking silly, but let's not make that one look silly. We can get rid of 2 more decimal places, so I'm going to go back in and do that one more time. Format cells, let's make it 7. Alright. Alright. Put some borders around there. So this guy up here, do all borders, and that'll be nice and pretty. This for style, I'm going to make that black. So we have the dependent variables with units, dependent variables with units. We have control condition and treatment condition, and the t-test that's comparing those two. Alright, everything looks pretty. This is a good table. I made it. Of course it's good. Control, copy. and drop it into your document. Control V. And there it is. So give it a title. These guys, it's a table, not a figure. It's table number 1. And we'll say summary statistics for the taboo experiment. And if it doesn't make sense in a particular spot up here, you can just add another sentence. All summary data can be found in table 1. Alright, we're kind of big on these beginning assignments when we're teaching you guys to reference the figures, so I would somehow call a point to that. Alright, like I said, we got to go back and do some formatting. We can see that when I copy pasted that guy in there, it got all kinds of messed up. So let me teach you another cool trick. So results, whatever it is that you want, set your font. We'll do, I like Verdana, but I don't feel like scrolling for it, so just for this, we're going to do Courier. Alright, that looks horrible. Maybe I'll go find Verdana. Alright. And Verdana. Let's do this as Verdana, but at 12. And now the special paste function is really cool. Oh, but I don't know this computer. I don't know where to find it. Oh, copy formatting. It's usually a paintbrush, or it looks like a roller paintbrush. Highlight whatever it is that you want to copy the formatting of, and click that. Then click everything else, and it'll copy it. Right? Now everything is size 12 and is Verdana. Alright guys, results. 24 young adults with an average age of 20 to plus or minus 2 years completed the taboo game experiment. Subjects were 75% female and were of normal weight. The heart rate before treatment was 79 plus or minus 10 beats per minute, and after treatment was 79 plus or minus 13 beats per minute, figure 1. Heart rate did not change as a result of taboo, p equals 0.09. Systolic blood pressure prior to treatment was ... You get the picture. Alright, I've got everything in here. I've referenced my figures, I've got units, I've got my standard deviation, I've got the averages. I have not given any kind of opinion in here as to why taboo had this effect. Honestly, I haven't even mentioned taboo other than to say that they completed the taboo game experiment. I have just told you that things are different or they are not different. That's the way I prefer you guys to do this. Then when you get to the discussion, you can start saying, they are different because taboo caused that difference. Alright, then you're going to try to explain why. Alright, let me scroll through the rest. We have figure 1 labeled. Make it bold if you want. Oh, it should be same text. Alright, so that was Verdana. Alright, do that for all the others. So we have one figure for heart rate, one figure for pressure, systolic, and one figure for pressure, diastolic. Alright, then we have our nice table. Control. Diastolic. Alrighty guys, that is all for the results. Start a new section, discussion. Alright, Talk to me if you're one of my students. Talk to me during office hours if you're still struggling with this. Hopefully these tricks in Excel will save you a lot of effort in creating this. All right, do it the way I'm asking, and you guys will get perfect points. The only way you're going to see points fall off is if you've actually calculated the statistics wrong and you report the incorrect statistics. But this is the formatting I want for my students. Alrighty? Good luck.